Units and electricity. Say you have a 60-watt light bulb and you leave it on for 8 hours, and your electricity costs 21.6 cents a kilowatt hour. How much does this cost for one day, and how much does it cost if you do it every day for a year? So maybe you have someone at home, a roommate or a parent, who yells at you, you left the bulb on, you're not paying the electric bill, blah, 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 running up the bill, whatever you're hearing at home. So let's analyze this mathematically. Okay, but first a quick review of some metric. And we're just going to hit the units that are most important to us: kilo, centi, and milli. So whatever the unit is, it can be anything. It can be watts, it can be meters. A kilometer is 1,000 meters. So kilo is always 1,000 times whatever the unit is. Centi is 1/100th. So a centimeter would be 1/100th of a meter, and milli is 1,000th. So those are principally the ones you encounter in common usage. And the advantage of the metric system instead of all the crazy numbers we have in the English system. So let's go on with our problem then. Electricity is watts times hours. Now watts on the bulb is an instantaneous number. You need 60 watts for that bulb to come on. So it's a sort of a measure of an instantaneous notion. Times hours is how long you leave the bulb on, which obviously influences how much electricity you use. 60 watts times 8 hours is 480 watt hours. Now notice this is a dash. This is not per. It's not watts per hour like miles per hour. It's watts times hours, and we indicate that with this dash. Now, to convert watt hours into kilowatt hours, which is what we're going to need because our bill comes in kilowatt hours, we have watt hours on top, and we want kilowatt hours. So I'm going to convert watts to kilowatts. And 1 kilowatt, 1 kilo of anything is 1,000 of the base unit. So we're simply going to divide by 1,000. You'll do these enough times. This step here, well, it shows our nice unit conversions. Obviously, dividing by 1,000 moves the decimal 3 places. So we get 0.480 kilowatt hours. And you see the beauty of the metric system compared to the English system. Now we're going to convert kilowatt hours to money. And the conversion was given in the problem that a kilowatt hour is the same as 21.6 cents. So doing the conversion, I cancel kilowatt hours and I turn them into cents, 21.6 cents. And I get 10.368 cents per day. Now before you throw a dime at whoever's fussing about the light bulb, if we do that every day, 10.368 cents a day times 365 days, we end up with 3,784.32 cents in a year. And obviously that would be 37.84 a year. So it actually is a waste of money to leave the bulb on. Small for one day, but if we all should try and be efficient with our electric usage.